Give me one example and the diagram for each. Come on. Give me an example of discrete data. Okay, I'll do the first one for you. Family size. Family size is an example of discrete data. It is explained yesterday only, right? Like no one will have 4.6 people in their families, right? And what is discrete data? The type of data which can take only some specific values. So this is an example. What will be the relevant diagram? Bar diagram. Continuous data. Weight, height, BMI, etc. These are examples of continuous data. Can we agree on this? Someone's weight can be 72.325 kilos. This is possible. This is possible. But our family size cannot be 4.3. So can we differentiate between different types of data? Possible. These two are quantitative data. And these two are qualitative. Give an example of ordinal data, come on. Or nominal data. First nominal data, tell me. I explained all of this yesterday. I'll come to the diagrams later. First, let's get on with the examples. For ordinal data, there should be a sequence in the categories. There will be no relevant sequence in the categories. Acha. Tell me one thing. Phone number. Is this an example of nominal data? Everyone convinced? Tell me why. It's a number only, right? It's a big 10-digit number. Then why is it not quantitative? Why is it qualitative? Anyone care to explain? Lie yourselves. Let me tell you. I think you gonna say. Order, yes. Exactly. So the simplest explanation is, have you ever tried adding two phone numbers together, or multiplying them, or dividing them, or subtracting them? No, right? It doesn't make any sense. It's a code. So phone number is an example of nominal data. Same goes with religion, patient ID, whatever. Now let's go on with ordinal data. Ordinal data is where there is an ordering. Say pain score. Pain score. You guys are familiar with this? Like how bad the pain is you're having. Grades. Education level. Etc. Understood, everyone? Now let's come to the diagrams. Bar diagram is possible here for the discrete data. For continuous data, what was it? Histogram. For nominal data, what was it? Pie chart. And for ordinal data, what was it? Bar diagram once again. Everyone knows why? Yesterday I explained why bar diagram for ordinal data, why bar diagram for discrete data, why pie chart for nominal data, and why histogram for continuous data. I explained it yesterday, right? So now no one will have a problem with deciding on which data, which kind of diagram to use for which kind of data whenever we are doing the analysis. Cool. Now coming to the actual analysis part. In descriptive statistics, what can we do? For discrete data, we can find the mean, median, mode, range, variance, coefficient of variation, and median in short. What more? We can do a frequency distribution, and we can do diagrams. Specifically bar. These are the kind of analysis we can do with discrete data where we have a number. We can find the mean, the average is easily findable. We can find the median, we can find the mode, we can find the range, we can find the variance. These are possible. We can find the coefficient of variation. We can find the frequency distribution. We can find the diagrams. Correct? Same goes for this. Just the diagram will change to histogram. Correct? But for three categories, we have A, B, and C. How can you find the average? Not possible. So here, for these two, only frequency distribution and diagrams, nothing else. So let's recap on the descriptive statistics part. Mean. What was the formula? Summation xi into fi divided by summation fi. Correct? For median, what do we do? For group data, for ungrouped data, the formula was this. There was no formula. We just find the cumulative frequency. What is cumulative frequency? The frequency we were calculating by adding it from the top. Remember? Like for 2 we had 3, 3 we had 4, for 4 we had 2, 5 we had 6. So there are 3 people who are less than equal to 2. There are 7 people who are less than or equal to 3. 9 people who are less than or equal to 4. And 15 people who are less than or equal to 5. Correct? So these are called the cumulative frequencies. So after that we find n by 2 and the number which just crosses n by 2, is the median, will contain the median. So what is it corresponding to? 4, the 4, so 4 is the median. And when there is no frequency distribution, what do we do? For odd numbers of data point, we find the n by 2th term and the n by 2 plus first term for odd ones, for even, and take the average. Say we have 2, 3, 4 and 5. So 5, there are 4 terms. So what is n by 2? 2. What is n by 2 plus 1? 3. So we detect the second term and the third term and then we take the average. What is it? 3.5. For odd, we take the n by 2th, n plus 1 by 2th term. So we have another number 6. So what will the median? 6, like there were, there were 5 numbers out here. So 5 plus 1 by 2, 6 by 2 is equal to, there are 3 terms. At the third term. So this will be the median. Correct? Sorry. Now, let's not focus on the mode that much. Mode is the thing which has the highest frequency. What am I explaining? Okay. Like if it looks like this, then this is the mode, correct? If it looks like this, then 2 and 4 both are modes. There are 2 modes and which are 2 and 4. Understood? So there is nothing to explain about mode unless you are doing it for group data. Now, range, what is the formula for range? Highest minus lowest. Two, 3, 4, 5. Range is 5 minus 2 is equal to 3. What is standard deviation? Root over variance. What is variance? One by n summation xi minus x bar whole square, and this is the only formula available. There is no other formulas. Everyone knows what this is. We just have all the observations at 2, 3, 4, 5. The mean is 3.5. So what are we doing? We are just subtracting. 2 minus 3.5 is 1.5. 3 minus 3.5 minus 2 minus 0.5. And then we take the squares. What will be? 2.25, 0.25, 0.25, 2.25. What does it add up to? 4.5 and 0.5. 5. 5 divided by 4. So, 1.25. Correct? So, the variance here would be 1.25 and the SD would be root over 1.25. Whatever it comes out to be. I'll calculate it for you also. This is the very SD. Everyone understood till now? And if there were frequencies, say this had a frequency f1, this one had a frequency f2, what would we have done? We would have just multiplied frequencies out here and divided this by summation fi. No difference. Correct? So what were we doing? After this sum, we are going to multiply this with f1, this with f2, f3, f4, and then we would have taken the sum, right? And after that we divided with the sum of this, just like we find average. Understood? Can you find the mean, median, mode, SD? Nothing. You can, but it's going to be very tedious. So what are we going to do? We are going to take the help of Excel. Correct? So today I am going to teach you how to do these things on Excel. That will be relevant only for the project, because in the exams you are going to have to do it on your hand only. But okay, but let's stick to what's relevant. What is this? We have a population. We can't go to everyone. So we draw a sample, describe the sample, and then we make a route map to the population. Correct? So this route map is called inferential statistics. There are many forms of inferential statistics. One is estimation. One is testing of hypothesis. This is not there in our syllabus. This is. So let's focus on testing only. So what is testing of hypothesis? Suppose we make a claim about something. Say a vaccine X is 70% effective. We draw the claim first. Okay, we make the claim first. Then we draw a sample and see whether our claim is true or not. This kind of analysis is called testing of hypothesis. Everyone understood? I am explaining once again. We have no idea about what this is. We have done a small study and then we have a faint idea about what it is, or maybe we don't even have. So first we make a claim that this is this. Okay. Then we identify the population, draw the sample, do the study, and infer whether my claim is true or not. This claim is called a hypothesis. More precisely, a null hypothesis. This is what you expect it to be. Yes, this is like you are making a vaccine or maybe making a medicine and you expect it to be 70% effective. Now I have to test whether your expectation is right or not. Understood? Or maybe that's the market standard, like you want a medicine which is say 90% effective. No other medicine in the market was 90% effective. You believe that it's 90% effective. So what do? You do the claim, then you study whether your claim is true or not. Okay. So this claim is called null hypothesis. It is denoted by H naught. Understood? So what will we be testing it against? Alternate hypothesis. That X is less than 90% effective. Because had it been more, it wouldn't have been a problem, right? If it is less, then it's a problem. If it is more, it's not a problem. And it's specific here only. Like in other cases, you can it can be more, it can be not equal to whatever. Here, I'm just telling it for the sake of the example. So this hypothesis is called the hypothesis which you are giving against your given hypothesis. It's called alternate hypothesis. And our the test procedure should be directed at trying to reject our null hypothesis. Whether either we get to reject it, else we claim that okay, we are failing to reject it. Okay, we can never claim that this is actually true in reality. This can never happen. So because there are always errors. So we always try to say that okay, even if this is getting supported from the calculations, we say that we are failing to reject this. Okay, you can do further studies if you want. But once this is accepted, okay, this is completely wrong. We can discard it. Understood? Now let's say we have a value 2, 3, 4, 5, 7. Okay, this is the sample I have drawn from a population of say 1 lakh. This is the population. I have drawn a sample of this size 5. Take an example. Okay, let's remove 2 zeros. From 1,000, we took this 5. I am trying to claim that the population average is 3.5. I am claiming that the average of this 1,000 observations is 3.5. But I have taken a sample of this versus alternate average not equal to 3.5. What was our null hypothesis? Mean is equal to 3.5 versus alternate hypothesis, mean not equal to 3.5. How will we do that? First, we are going to find the mean of the sample. What is that? 4. Okay, no, let's not generalize. Let's keep it general. Let's generalize it. We are going to find a function from the values of the sample. We are going to draw a mathematical function from the sample. We know how the frequency distribution of this function will be. We know that. That's how we are making it. See, it goes like this. Now I have told previously that there will be some error. So I had said previously that there will be some error. There will be some error. What is the error? Some allowable fluctuations. How does error arise? Let me explain that first. Say we have a class. A class where I am just concerned about the marks obtained by the students of the class. So say there are 150 students. I take a sample of 15. I take the toppers. I take the top 15 students. The average will be high. So my conclusion will be that the average marks of this population will be high. That's a error. Say I take the last 15, the worst 15. So the population will go low. Population average will go low. So what kind of bias are these? These are called selection bias. So there are different kind of biases which give rise to error. Okay. So we are going to allow 5% error. We are going to allow 5% error. And what is the alternate hypothesis? 3.5. Not equal to 3.5, right? So we are going to distribute this 5% area on both the sides. 2.5% area here, 2.5% area here. Now, if the value of the function obtained from the sample falls here or here, then we can claim that, okay, out of selection bias, a variation can occur, but it should be contained in this region, not in the 5% error region which we have left on both the sides, correct? These cutoff points are specified. Say for 5% error in a Z test or in a Z test, the cutoff points are 1.96 and minus 1.96. These are constants. Okay. If the functional value goes over 1.96 or less than minus 1.96, we are going to say that this is true. The alternate hypothesis is true. This is blatantly false. If the value lies here, somewhere greater than minus 1.96 and less than plus 1.96. So we can say that, okay, we have not enough evidence to support this, but okay, we cannot reject this. That much. Okay. So now we know how to do a test. Now these functions will be specific for different tests. Okay. I am gonna just write down the different functions for different tests and you're gonna memorize them. Okay. You will be given the cutoff points or you have to memorize it. I'll just tell you at this point and you can do the test accordingly. Not very difficult. This function will change for every different tests. Okay, nothing else. These cutoff points and these cutoff points will also change and that will be given to you. But the test procedure will be the same. You find the value of the sample function from the sample, compare it with these cutoff points, whether it goes above it or beyond it. If it is true, if it goes beyond it, then this is true. And if it falls inside it, then we have not enough evidence to reject this. That's it. Data was of two types, qualitative, quantitative. So tests will be also of two types. What are quantitative tests? Here we are gonna compare the means, say the average. Say I have one sample, say I have another sample. This is coming from one population, this is coming from a different population. We are concerned to see whether this average, say I am denoting it by mu1, and this average which I am denoting by mu2 are same. So null hypothesis is mu1 is equal to mu2. Correct? Alternate can be mu1 not equal to mu2, mu1 less than mu2, and mu1 greater than mu2. Whatever suits our requirement. How do we find the average? How many are there? There are 14 data points. 14 data points. So what are we going to do? Average. You know how to make the average. So now for the standard deviation. Why did I add a dollar sign? Why did I add a dollar sign? See, if I am subtracting this from this, okay? See the result is here. Once I drag the result, these are our input will come to this input. This will also change to this. Nothing is there. We take it as 0. Right? So, but we don't want that. We want this to be subtracted from each of the data points. So, we added that dollar to keep this also. To keep this also. Understood till now? And hardly 50 minutes I'm going to do. So, you guys also have lost your attention span. What is power? I'm just going to leave it power. Here I want to square. Let's square it. Now I drag. Now let's find the average. Now let's find the square root of this. Let's see what it is. 4 for square root. This is standard deviation. So we know how to calculate standard deviation without using a 10 or a calculator. This is how we are going to do it. Now let's see one. How can we represent this as a diagram? First, let's make a frequency distribution out of this. So how can we do that? We are going to insert, write this out. We are going to insert and then pivot table. Understood? Write this out. This is the table range and the location I have just clicked over here. Okay. Here it is. So let's drag this variable on anything. Say roll. Okay? Sorry, great. I need serial numbers. Okay? I got the serial. Insert pivot table and we draw this. Okay? Now let's insert our pivot tables. X goes on values and serial number will go to X goes on row level and serial number goes to values. But we have to change it to count. What we used to do, we first used to keep tally. Okay, 2 we got tally for 2, 3 we got tally for 3, so 4 we got tally for 4. But here it is zero understood? Now how to draw a diagram? It is just select the table and just Alt F1. Let's change the names over here. So now you know how to draw diagrams. Understandable? So let's summarize the steps. You guys editor. For pivot table, we will need a serial number column. A serial number column. Take a serial number column and have the data. Click on the place where you want the table and then go to insert pivot table and click on pivot table. And after that select the whole data including the serial numbers. Okay. See this thing has been selected already as the location. And after that, after you have done that, just click on OK. After that, you put X on the row column level or the row level, whatever you feel. Let's say we put in column. But serial number will always go on values. Click on this value field settings, count. Okay, done. So you have the table over here. Now what are we going to do? We are going to select this.